Okay, on these two graphs that I drew last, there are 2 points on each of these graphs which are much more important than all the other points, and they're called the intercepts. So this one right here, for example, is called the y-intercept, and it's called the y-intercept because it's the spot where we cross the y-axis. And similarly, this one's called the x-intercept. Now notice what's happening on this y-intercept. This y-intercept is the point 0, 2. When you have a y-intercept, when you're going to be a point on this y-axis, your x value is always going to be 0. Conversely, the x-intercept here is the point -6, 0. You're on the x-axis. On the x-axis, the y value will always be 0. Now let's look at this line down here. We have the x-intercept right here, -10, 0. Again, on the x-intercept, the y value is 0. And here we have the y-intercept. The x value is 0. Alright, so the next couple problems you're going to be asked to do, you're going to be asked to determine the x and y intercepts and use them to graph the equation. So, remembering what we saw here, to find the x-intercept is going to happen when y is 0. So to find the x-intercept, I want y to be 0. So I'm going to take y equals 0 and I'm going to plug it in here. -2x, if I plug 0 in, 4 times 0 is 0, equals 8. Divide by -2, x is -4. So my x-intercept is the point -4, 0. Similarly, for my y-intercept, remember what happened here? For the y-intercept, the x number has to be 0. So when x is 0, I'm going to plug 0 into my equation up here. 4y equals 8. Divide y equals 2. So I have the point 0, 2. Alright, so that gives us 2 points. When we have 2 points, we can draw our line. So -4, 0, 1, 2, 3, 4, there's -4, 0. And instead of scaling my axis this time, I'm just going to label my points. That's an acceptable way of scaling your axis, of indicating the scaling of the graph. And there's 0, 2. I can connect the dots, and I have my line. Now, quite often students will tell me, if I give them this problem and I just say graph, quite often they'll say, well, in order to graph, I need to get y all by itself. And the truth is, that works just fine. But it's a lot of work. My opinion is it's quite a bit easier to compute the intercepts, especially if I have a problem like this. Because of these fractions here, getting y all by itself is not going to be real easy. And when I get y all by itself because of these fractions, I'm not convinced I won't have fractions that I need to deal with anyway. Kind of a pain in the neck. Personally, on a problem like this, I think it's a lot easier to find the intercepts. Alright, so let's find the x-intercept. Again, to find the x-intercept, we plug in y equals 0. So we're going to have 1/2 times x minus 0 equals -1. To get the x all by itself, we multiply this whole equation by 2. X equals -2. So our x-intercept is -2, 0. And notice that was really quite simple, I think. I didn't have to do a lot with the fractions. I didn't have to add, divide by fractions, that kind of thing. All I had to do was multiply by 2 to clear that fraction. Alright, let's find the y-intercept. To find the y-intercept, it's going to look like this eventually. I plug in 0 for x. If I plug in 0 for x, I have -1/3 y equals -1. To get the y all by itself, I take that equation and I multiply by -3. So y equals 3. So I have my y-intercept. 1, 2, 3. Again, I can either label the little tick marks, or I can simply mark my points. In this case, I'm going to mark my points. And there they are. Draw the line. Okay, at this point, once again, please pause the video and take a look at the next 3 problems. So you should be doing problems 5, 6, and 7. The last thing we need to talk about in this section are some specialty lines. For example, a specialty line could be the line y equals 4. And this tends to bother students that there's no x value, but there doesn't need to be. Remember, we talked about that early in this section. I guess I'll put a quick scaling on my axis here, and then I'm going to plot some points, and I'll draw the line. So, let's say I plug 0 in for x. If I plug 0 in for x, y is 4. How come y is 4? Because y is always a number 4. That's what it says there. If I plug -3 in for x, y is the number 4. If I plug 12 in for x, y is the number 4. It doesn't matter what number I use for x. No matter what number I use for x, y is always the number 4. Alright, so I have 0, 4, that's right there. -3, 4. That's right there. 12, 4, that's somewhere over here, like so. Notice what's happening. Y equals 4 is a special kind of line. Y equals 4 is a horizontal line. So in general, y equals a number is always a horizontal. I have trouble spelling that line. Conversely, our last special kind of line, let's say I give you x equals a number. Well, again, a little bit weird. The only number I can plug in for x is -2. But I can pick any number for y. X could be -2, y could be 1. X could be -2, y could be 0. X could be -2, y could be -4. Y can be any number I want. Pi, I haven't used a pi yet. I'm not going to try to graph that, but I could. Alright, so -2, 1. This time I'm choosing to label my points rather than label my axes. That's okay. -2, -4. Notice what you end up with here. X equals a number gives you a vertical line. So those are the 2 specialty lines that you need to be. Oh boy, I kind of missed my dots there. Oh well, wasn't very good with my ruler. Those are the 2 specialty kind of lines you need to be aware of. Again, y equals a number is always going to give you a horizontal line, and x equals a number will always give you a vertical line. Go ahead and do the last 3 problems on your sheet, and make sure you bring that to class next time.